Going ahead and looking at the shape, vertex, and slope for an absolute value function, we notice that we have this form y is equal to a times the absolute value of x minus h plus some k. Now, a is just some constant number, kind of like a coefficient is in front of like an x. So we have some constant. And you could kind of consider this as one big x. So that would be like, maybe if this a were 2, you'd have like 2x plus some k. So k is also some number, some constant. And likewise, so is h. H is just some constant. So a, k, and h are just some numbers. The only thing that's really not is this x and y. Now, when we're talking about the shape, we're referencing that this thing is either opening up, this v is opening up, so you might see something like this, or it's opening down, in which case you'd see a v doing something like that. So when we're talking about the shape, we're meaning up and down. The vertex for this particular absolute value function just comes out to be taking the opposite of our h, so h, comma, and then we just take k just as he is. And so if you're a little hung up on the hk for the vertex, don't worry, we're going to see several examples of that. For slopes, that's actually controlled by our a value in front. So notice how it says slopes, plural. That's going to be controlled by a again, which is positive a and negative a. And the reason why we have that positive and negative a is if you were to graph an absolute value function, maybe you'd see something like this, where you end up with the positive slope, and then you reach your vertex, and then all of a sudden the negative slope kicks in. All right? So again, here would be that positive a impacting it, and here's the negative a impacting it. So now, using all that information to look at example 1, we are asked to graph the following using the vertex and the slopes. So just looking at the vertex, we are going to go ahead and take the opposite of this value. So we end up with negative 3. That's what controls our x. And then for our y value, we just basically drop down this k value. So we end up with negative 3, negative 1 as that vertex. Notice it's an actual xy coordinate point. So we end up with negative 3, negative 1 as the vertex. Now with that vertex, you actually create that mirror that we were talking about in class. So you should end up with this mirror where the left side matches the right side. We'll see that as we look at the slopes. So for our slopes, our a value happens to be 1. If there's not a number written there, it's assumed that it's 1. So our slope comes out to be 1 and negative 1. And because this guy is positive, this thing should be opening upwards. So we should end up then with a slope from our vertex of positive 1. So up 1 over 1, up 1 over 1, up 1 over 1. And the reason why it's going to be opening upwards is because, again, this value is positive. Now comes in our negative 1 slope. Well, that would be like going up 1 and to the left 1. Up 1 to the left 1, up 1 to the left 1. And there you can kind of see that negative slope happening, that negative 1 slope. So then, more or less, this is our image for the first graph. And notice, too, that the left side is mirroring the right side. So that's pretty much how we're finding these vertexes and the slopes. Looking at this one, we notice that we don't actually have an h value for our vertex. We actually do, believe it or not. If we were to actually rewrite this as y equals negative 1/2 times the absolute value of x plus 0, really if we're just adding nothing to it, we haven't changed it. So these actually mean the exact same thing. And then finally plus 4. These actually mean exactly the same thing. So for our vertex, we're taking the opposite of 0. Well, 0 is a neutral number, whether it's positive or negative, so it doesn't really matter. It's still going to be 0. Then for our k value, again, we took the opposite for our h. The k value, we literally just drop down. So he's positive 4 at the end there. For our vertex, he's just going to be positive 4. So our vertex comes out to be 0, 4, which is right there. And again, the vertex creates our mirror. And that's really why we care about the vertex, to see that mirror happening. Now come in our slopes. Well, we see that we have a slope of -1/2. But because we're looking for both of them, pretty much you just take the opposite of this -1/2 and get +1/2 as the other slope. So from our vertex, because we have an a value that's negative, it should be opening downwards. So you should be then going from our vertex down 1 over 2. Down 1 over 2. Down 1 over 2. That would represent our negative slope. The positive slope would be when you go down 1 to the left 2. Down 1 to the left 2. Down 1 to the left 2. So here again would be that positive part of the slopes. Get to our vertex, then we end up with our negative slopes. So more or less that is what our V should look like. Getting to C. For the vertex, we just take the opposite of that guy, that -1. So, looks like he comes out to be +1. For our K, we just drop him down just as he is. So it looks like our vertex is happening at 1, -2. So there is our vertex. Again, with that vertex, we have our mirror. Now focusing on the slope, well, we see that we have -3 as our slope. Taking the opposite of that, we also have +3 as our slope. So from this point, because he's negative, we're going to be opening downwards. So from that point, we're going down 3 over 1. Down 3 over 1. And again, this really should mirror this. So see how this is 1 unit to the right of our mirror? We should go 1 unit to the left of our mirror. Likewise, this guy. So 2 to the right of our mirror, we should go 2 to the left of our mirror. So then we end up, and we can even see that here is our +3 for our slope. You can see it as you get closer to your vertex, +3. And then we reach our vertex, and now here is that -3 for that slope. And so that is our graph for C. So again, though, that is example 1 from our 2-7 number 1 set of notes.